hear me well? Because I can... No? Not really? Okay. These parts are not that important for the content. Yeah, actually I could do that. I could jump and talk there because I also have this. And that could be maybe more interactive. Yeah, I will start the presentation in a few minutes if we have a microphone, or if we don't, I'll go there and talk. But before that, I'd like to ask a couple of questions. And first of all, thank you for coming here today and to hear a little bit more about microservices. This talk will not be that heavy on the actual tech, but it's a little bit of a soft talk where we have to see what you have to embrace for the changes to adapt to microservices. So the question is anybody using microservices in production? In production? Okay, perfect. Now, this is a very important question. How many of you have more than 10 services? 1, 2. Okay. Good. I will talk about what is a microservice and what is not a microservice here in this talk. And I will try to clarify the ideas behind it or around it. Because actually it's a little bit a hype. Like everybody's talking about microservices. You see like all the other tools that you are used to using, like Nginx and Redis and then RabbitMQ or all the other queue mechanisms. They are now marketed as microservices tools, but actually they are not. And I will try to highlight some of the differences of what makes a good microservice and what not. Any microphone? No? Anyway. Now can you hear me? Back there? Okay, I can continue like this, no problem. All right, a little bit about myself, still to gain some more time until we may have a microphone. I'm Armagan Amcalar. I come from Berlin, Germany, and I'm the head of software engineering at a company called UNU GmbH, UNU Motors, and we are basically building electric scooters, and we are creating solutions for the future of mobility, like mobility services. You are all used to Uber here, I guess. It's one type of a mobility service, and then there are a lot of other types, and we are building solutions and mainly software and hardware as well for creating or defining how people will move in the cities in like 10 years, in 20 years. And yeah, we have a, let's say, a small software engineering team there, and yeah, we're working on the software side. I also write a lot of open source code available on GitHub that range from, I don't know, brain signal processing to front-end frameworks to microservices frameworks and more, actually. So if you like to see some new repositories, I would encourage you to check out my GitHub profile, and the links are here. Obviously, the presentation is already online, and I will share the link in the end as well. So you can click through whenever you like. All right, so today we will try to answer a seemingly easy or trivial question. Your team or yourselves as developers, you want to adopt microservices. You want to start using microservices. But the question is your organization actually ready for the challenge? Because although it's really a big hype at the moment, and you can read a lot of articles of how to implement microservices, it's not only about the source code, it's not only about the environment, it basically requires your whole engineering department and your whole company structure to change to adapt to microservices. And it actually has some implications even for marketing as well. And yeah, I will talk a little bit more about that in the coming minutes. But the thing is, it's not only a technical implementation. You can do everything right technically. Oh, okay. Hey, is it better now? Yeah. Okay, perfect. Then I don't have to shout. That's better. So you may do everything right technically, but it doesn't mean that you will be successful as an engineering team to implement microservices if you don't have some of the other aspects right. And basically, today we're going to talk about those. So let's start with the definition of a microservice. And I guess, how many of you have read an article about microservices? Yeah, it's just a single article. Everybody has a definition, and mostly some of those articles are written by people who are using the current tools, and they are kind of, marketing those tools. Hey, Redis is a great tool for microservices, blah, blah. And therefore, there are a lot of skewed definitions of a microservice, but actually, most of them are just wrong. So let's start with what is not a microservice. If you have queues in your system for example, notifications, emails, or reconciliation services, let's say you're building an e-commerce website and people are purchasing products with a payment provider like PayPal, whatever, and at the end of the day, you run some reconciliation jobs with PayPal to see if the numbers still fit. If if you think you should get $1,000 and then PayPal thinks that they have to give you 500, that's a bit of a problem. So you have to solve that. That's called reconciliation. And usually these stuff run with queues, right? And then you might have some logging services, some behavior analytics services in your code. And most people will tell you that these are actually microservices, but they are not. If they are depending on queues to function, and if they're not core to your business, they are actually not microservices. Even if you have 50 of them, it doesn't mean that you're doing microservices. Even if you are running multiple programs in your servers that communicate over HTTP, it still doesn't necessarily mean that it's a rightful microservices architecture. So what is a microservice then? Okay. There is a very simple definition. If you're breaking down the fulfillment of a single HTTP request on your web application or on your mobile application to multiple collaborating services that may or may not run in the same server, that may be distributed horizontally, then you can call it a microservice application. So here's an example. Again, an e-commerce application. Who did e-commerce applications before? Very few people. This is very interesting. What are you working on? You're really lucky if you didn't have to build a web shop, basically, a place where people has to buy stuff. It's really, like, when the money is involved, it's really, really bad. So most of you buy stuff online, right? You add something to your cart, and then you go to the checkout, you enter all the details, and there's a single button, and when you click it, basically some monkeys hit some keys in some servers, and then shipment is done, invoicing is done, some money has been deduced from your account, and then a few days later you get a shipment to your door. So there's a single button and a single API call that is triggering all of this. And up until this point, we were used to doing this with a monolith, which means a single application, like a PHP application or a Java application, that basically does all of these actions sequentially, one after another, in a single command. And if you're doing microservices, basically you have separate services for catalog, for stock management, for shipments, or for deducing money, like payments, and for generating orders or for generating invoices. And that single click actually is fulfilled by, I don't know, maybe 10, 15 different microservices working together to basically give you a response, what is the status code of a successful HTTP response? What? 200, yeah. Basically, in the end, you get a 200 OK response, and there are multiple ways of doing this. And if you're breaking it down to individual services that run in their own memory space or in their own containers, then we can talk about a microservices implementation. And basically, this is the baseline. Of course, there are a lot of best practices that you have to implement if you want to get serious about microservices. And anybody familiar with domain-driven design? Good. It's basically a book. It started with a book, I guess 15 or 16 years ago. I encourage you to read it. It's kind of, at least for me personally, one of the best ways to do software architecture. So it breaks down the problem of delivering an application into something called domains or contexts or bounded contexts. Now, it's not the point of this talk because that's a lot of technicality, but I would encourage you to read more about domain-driven design and how to do microservices properly. But again, the idea is to break down the request-response flow of that single request into multiple different programs or services working together to implement one single request. For example, if the shipment is not working, you probably won't get a 200 or an error will be thrown somewhere and logged, but still it's a different service that's on its own. So one of the biggest benefits is obviously if there's a bug in one of your systems or if it's lagging, if it's slow, it doesn't bring down the rest of the system. So let's say PayPal is really slow to respond to your payment requests, fine. People can still browse your website. They can still check the stock or enter new products or see the catalog or the categories. It doesn't matter. Or see the recommendation engine. Because payment is another service, and as long as nobody is trying to make a payment within your website, they will be able to freely browse the website, which is not, of course, the case with a monolith, because you usually allocate a thread for each request, incoming request, and if you have like 2,000 payment requests waiting, mostly doing nothing, then you are probably out of your servers, and then all of the rest of your website will slow down with that. And the good thing is with this, it actually scales really, really well, because if there's a problem with the payment service and you want to scale it, well, you can. Doesn't matter, because it's a single service. You deploy it to multiple machines, and you don't have to scale the catalog service, or you don't have to scale the back office or anything else with it. And of course, you would have to if it were a monolith, if it were a single binary that you deploy. Another good thing is, since they are separate stuff, separate services, they have to have a clear, well-defined API. Maybe an HTTP API, a REST API, documentation as well, so that different developers can use different services. It lets you think more in organization and forces you to, for example, separate your models. Just that, hey, okay, it's better. Let's say there's a payment service and it needs the credit card details of the user. Normally, you would just access the user table from the database and get the credit card details. If you're doing microservices, that's not going to happen because users actually belong to another service called user service. So you have to use an API from the user service, give it a user ID, and receive the credit card details. So it basically forces you to write separated code, which basically is a good move towards single responsibility of your code base. So again, you have to use clear interfaces between your services, basically. So that, and we'll talk more about this, it's mainly about the reducing the number of bugs in the system that happens due to the complexity. It's basically about reducing the complexity of the overall system. And there are several other stuff that I will briefly mention. And for example, one of them is auto-discovery. Because if you're really doing microservices, you'll be running maybe 50 or 100 of services at any given time in production. And I'm not talking about copies of services. Like, they will be different, unique services. And there has to be a mechanism to make sure that they can communicate really well. Who remembers the times that we entered IP addresses manually in our deployment systems, saying, hey, I want to deploy my application to this server and then to this server? Who remembers those times? Okay, very few people. Again, you're really, really lucky. But basically the problem was you have a fixed pool of servers. You have 10 servers, and then you enter the IP addresses of all those servers, and you configure the port numbers. Hey, my application is on this port in this server. And then, you know, what happens if one of the servers fail? Well, you have to buy a new one, which will ship in 2 weeks or something to your data center. And then you allocate a new IP address to it. So you have to update your continuous deployment tools or continuous integration tools to make use of the new IP address and new port numbers. And then you bring in a new service because you are kind of now doing microservices. You decide that you want a new service. Okay, it has to be allocated a port number and it has to run on a server, right? How do you do this? It's a lot of manual configuration. And if you are really serious about microservices, all the configuration has to be automated, and also the services basically have to discover each other automatically. There are a lot of mechanisms for achieving this, and nowadays the orchestration services like Docker, Docker Swarm, or Kubernetes kind of give this out of the box for you, so you don't have to do a lot of manual configuration. Who's using Kubernetes? Good. Docker Swarm? All right. Do you know that there is something called Docker Cloud? Well, two. Okay, check it out. It's basically a software as a service orchestration tool, much like Google Cloud Platform, and it's a tool from Docker, basically the same company. All right. Another thing is, now that it's really easy to scale out individual services, you should be running multiple of them in production so that whenever one fails, it doesn't matter, the requests will be forwarded to a second copy. And it's a lot cheaper because you don't have to scale all the application again and again for each server that you add. There's another best practice called favoring kettle over pets. Did anybody hear this before? One. Okay, this is one of my favorite best practice. Does anybody have pets, like cats, dogs? Cool. All right. So you call them by name, right? And you love them, you care for them, you feed them. They get sick, you take them to a vet, and basically they are a part of the family, they're a part of you. Whereas, and this is only an analogy, or a metaphor, so bear with me. And then there are cattle, like a herd of sheep or cows. And if you are, I don't know, a farmer, you mostly maybe care about the amount of milk that you get from those animals. And you don't necessarily know each of them by name, or your workers don't necessarily know each of them by name. And yeah, they may die, but they also reproduce, they get replaced. So as long as you can still produce that amount of milk, that's fine, or that amount of meat, that's fine for you. So this is basically what we are trying to do with servers as well. You should have a server pool, like 20 servers maybe, or 30 servers, whatever, but you don't log into them via SSH. You don't give a name to those servers. You don't even create them yourself. An orchestration tool automatically creates them for you. And the SSH part is really key. Like, you shouldn't have SSH access to your servers. Everything should be automatically configured and deployed and upgraded and rolled back for you. And basically that's called favoring cattle over pets. So there are some pitfalls to microservices, and it's really easy to make these mistakes. One is you're dividing your the problem that you want to solve into different servers, into different services. But how do you make sure you made that division correctly? What happens if every time you make a payment, you also have to do a lot of user requests, and then user service is another service, and like you have to do joins not in the database right now, but over REST API responses or JSON, for example. It's really hard. Maybe there is a better way of doing this. Maybe you need to combine those services. So one of the biggest pitfalls when designing microservices is basically you start with an idea and not a live product, not a live running microservices application. And while you're doing that, you discover that, okay, this architecture is not right. And I need more services, or I need less services, or I need to share responsibilities between these services because it's not working. Like these two services are really highly coupled, and then there are like thousands of requests going in between them, and it's really hard to do. Another thing is error handling and circuit breaking. If you remember the example that I gave about, for example, shipments in an e-commerce application, how do you, let's say your shipment provider stopped responding to your API requests. How do you make sure the purchase requests will be prevented from going to that shipment provider? Because maybe they are just responding too slowly. They're responding in like 25 seconds, and there's a huge load that's building up there, and not a huge number of requests that's just building for shipments. Is there a better way to, let the user know that, okay, shipments are not working well, and we cannot sideline it, so maybe do we disable purchasing so that we reduce the load in those, in that shipment server or service? So this is called basically circuit breaking. If there is a service that is loaded, you have to break the circuit before the request comes to that service. So basically, you don't contribute to that load further. So fault tolerance is also something similar to this. How do you make sure that the faults that happen in your payment service doesn't really, again, bring down your whole website or your whole user experience? It's kind of impossible to do right monitoring. Beforehand, for example, you would implement an HTTP health check, and you would ping your website, for example, or your payment endpoint, whatever. And if you got a 200 response, it would be fine for you in terms of monitoring. Now you have like 100 services. You have to monitor each one of them separately, and it's really, really hard to do. And when you get down into the details, when you have like 50 services or more than 20, it's really hard to get the big picture. Basically, no one in the team knows how a request, after it starts, how it will end, like where it goes through the individual services and where it will end. It's simply impossible if you have the right tools. But here's the thing. This is cool. Wow. 10 minutes? Okay. I thought we had time until 1. Okay. All right. Anyway, then I have to go really quickly. So basically, you will have to embrace change, and everything will change. Like your code repositories will change rapidly. You will be building new versions of your services all the time, and you have to do version management because the payment service is configured to work with user service version 1.2.0, and now the user service team deploys any version to production because they are free to do so. They are a confined team, and nobody tells them, hey, now you have to deploy to production now. They are free to deploy whenever they want because this is a change required by microservices. How do you make sure that user service version 1.3 still works with the payment version that is already in production, that it doesn't break? So the thing is, you won't deploy to the production weekly or monthly or whatever you really have for release schedule. But all the parts, all the different services will be able to deploy automatically whenever they see fit, whenever the team wants and sees the code base as ready. And this is a huge change that we have to embrace. So it requires a mindset change. Basically, you have to own this. Like, everything is bound to change. You will see that code will break, dependencies will break, somebody will push a new version, and now the test environment will, throw 100 errors because it's not compatible with other services, and this will lead to a lot of frustrations in your team as well. So this is a different mindset. You have to embrace that there will be errors, mostly caused by humans, but you have to make sure with proper architectural documents, for example, or proper integration testing, or end-to-end testing, that nothing is breaking. So if you're breaking down the payment into 20 different services, you should have really end-to-end tests that will cover all of the scenarios, all of the edge cases, so that you make sure, even if there's a very small change in one of the 20 services, your payment will still work. This is really hard and really tricky to do. But of course, if you can do this, people will really own the code, because they will be assigned a domain like payment or user, and they will know the ins and outs, and they will have a clear API documentation for the rest of the company, for the rest of the software team. And like, it's really, really good to see that people know what their friends are working on at the API definition level. Because it's really tricky to get, to know the parameters of each function request for the models, etc. But when it's a REST API, and it's really easier to see that, hey, yeah, the payment gives me only these, and I need these information. How can I bring these bricks together like a Lego and make a meaningful answer? So you need to have some infrastructural changes. Basically, your continuous integration and continuous deployment tools should be rock solid. Anybody using Jenkins? Cool. Using Jenkins 2? No, Jenkins 1.6, are you? Yeah. So Jenkins 1.6 won't cut it. You need pipelines. You need to have different stages of builds for each service. And that matrix, there's a plugin for it in Jenkins 1.6, but it doesn't really cut it. But Jenkins 2 supports it, and like there are lots of other tools who support it as well. Basically, you have to use containerization. You have to use Docker in your applications, because otherwise it's manual deployment, and you can never make sure that the binary that you deploy is immutable. Like, this is the SHA that I deployed, and whatever happens, wherever I deploy it, it runs exactly the same. Whether it's on the developer's computer, whether it's on a server, it will run exactly the same. This is one of the things that you have to get. And again, you have to invest in monitoring heavily. I cannot stress this enough. Like, monitoring is really key in this. A benefit is basically you don't have any vendor lock-in. You can migrate from cloud to cloud. And as an example from our experience, we were running in DigitalOcean. Then AWS decided to give us some free credits, and we moved to AWS, the whole production system with more than 20 microservices in about 10 minutes with zero downtime. And three shell commands. Build up a new data center in AWS, a new server group, deploy it there, reduce the number of servers in DigitalOcean, and then the migration is done. Basically, this is enabled by Docker, Docker Swarm, or other orchestration tools that you're using. And it's a wonder that you have this ability. Again, people who were used to configuring servers in the past will understand what this means. Like, where machines required a lot of manual configuration. So you have to embrace some organizational changes. The team structures will change. You will have to eliminate hierarchy. There won't be any guy going around and say, hey, we're doing a new sprint, and we will do a new release at the end of this 2 weeks, and like, everybody get ready. No, this won't happen. And basically, you have to do really, really good release management in the background by monitoring your teams. Some of the teams will deploy like 10 times a day. Other teams will deploy maybe 2 times a year, and you have to make sure everything is working and everything is in sync, and the versions of every service is basically known, and there are no surprises in the team. You won't have hierarchy, and people will be able to use whatever tool, whatever language they they want for each microservice. Maybe it's you are doing analytics, and maybe it's easier to use R as a microservice there for doing analytics, or Rust for, I don't know, for system text or for machine learning. And you have to let them do their own work, and as long as they provide a REST API or something that you can work with or others can work with, you have to let your teams free. And this is really hard for managers, especially like project managers, because you are kind of losing the big picture again, and you have to find other ways to basically keep a consistent vision. Hey, people, this is where we're going as a direction, so be prepared for this. And for me, the easiest way is architectural documents. Anybody remembering UML diagrams here? Yeah, they are really key in this transformation. Nowadays in the industry, people hate UML diagrams, but in fact, if you're doing microservices, you cannot live without proper service definitions and UML diagrams. So when you do this, the biggest problem that are in different teams is blocked by hell, which means, hey, I am a team of developing payment, but the purchase team didn't do their job, and I'm blocked by them. I cannot work. This is a common scenario that you see in different or distributed development teams. They accuse other teams of not doing their jobs, and that's why they're not doing theirs. And basically, you solve this problem because everybody, there is now autonomy, and everybody is working alone in their own space, and they conform to an API definition. So here's the conclusion. This was a very fast talk, and I hope we'll have a couple of more minutes with the questions where I can answer some of your questions. But the conclusion is, microservices is, again, not only a technical implementation. It requires a whole change in DevOps, in mindset, in team size and team structure. And if you can do it right, it will basically supercharge and enable your organization to deliver faster, deliver more features. And yeah, the future is really, really bright with microservices. And the game is afoot. Thank you.
Thank you. Any questions?
Yes,
yeah.
Hi, Armagan. Thank you for the speech. And I have 2 questions. They are connected with each other, and they are connected with pitfalls that you named. What is the main strategy when migrating from monolith application to microservices? Are they called sequentially or in parallel? And connected question, how to check how to fall back the work of microservice if another microservice is fault?
Yeah. So for the first question, migrating from a monolith to a microservice, it's really hard. Because if you're doing a monolith, and if you're used to doing a monolith, probably your models are all around and your domain services are using multiple models interchangeably. Like there are 10 different domain services that talk to the same number of models. So it will seem that it's kind of impossible to separate them. For me, the best strategy is, and it may change depending on the application, of course, pick a single model with the least amount of connections to the services. So the least widely used model, and turn it into a microservice for that model only. Now, usually it's not the best practice to separate your microservices by each model, but it should be by each domain at least. But it will force you to think in terms of APIs, to think in terms of REST APIs. And starting from there, you will work back to your services and see where you can use REST APIs to do the model calls, the method calls that you were previously doing. And then pick the easiest service that again has the least amount of connections or coupling to the rest of the system. And usually people say it's like logging or something, or emailing, because like they are really confined, but I'm not talking about those. Pick something real like payment or reconciliation, and or catalog or stock management, and try to build a prototype around it to see how it would act if it were a separate system, and refactor the rest of the models or the rest of the controllers that work with that service, because now it's a different application actually, like a different payment provider that you are using over the REST API. That's what basically your microservice will be, and you have to try it out and see. It's really, really painful actually. And the second question, or there was another one, like parallel or sequential. Basically, it's a process. Some will be in parallel, some will be sequentially triggered, and you have to have a very good control flow for this, because like currently, for example, we have a request to book a scooter, and then it touches like 25 different services in various configurations. Some of them are parallel, wait for each other. Some of them are sequential, as you said, like payment. It's really, really hard to get it right. That's why you have to have a really nice architectural documentation and a very good control flow library to make this happen, and to prevent, for example, memory leaks as well. Because if things are parallel, then you may miss some of them. It will lead to some memory leaks maybe. And the other one was, sorry.
How to prevent...
how to do circuit breaking and how to prevent the others from failing. Basically, we did this by implementing our own rollback mechanism in the database. So whenever there is a request coming in, we are opening a new transaction, and like every service is writing a log to that transaction. And if some fails, if one fails, you know all the steps that have been taken until now, because this is an asynchronous process, right? You cannot just easily roll back, like each service cannot roll back its own. That's why you need a log of actions, and maybe another service that will take this log, reverse it, and apply it back to each service so that the changes that they have done are basically rolled back. Again, this is really, really tricky, and if you don't get this right, you shouldn't go to production.
Am I understand it right that this log service is a single service for all the microservices, or it is in a transaction in each?
Yes. Basically, the rollback service is single, but every microservice is of course responsible for writing its own log to this transaction. And yeah, of course, it's a little bit more complicated than this. You have some other services to make sure transactions are healthy. There are no transactions that are left dangling, like nobody wrote to it for 10 minutes and it didn't end, but it didn't fail also. What's going on? You have to also inspect it and roll it back. So it's really kind of a mess, actually.
Thank you.
No problem.
More questions?
Here.
Okay.
And like I'll be around all day long, so don't hesitate to pull me whenever you see me around.
Hi, thank you for your speech. My question, I have two. First question is, do you recommend start new projects from microservices, or maybe begin with monolith and then split when we more understand our business? And second one, more technical, what protocol do you recommend to interact between microservices? JSON REST, I think, have a huge overhead, and maybe something.
That's a very good question. Okay, so basically, let's start with the second one. I'm talking about HTTP services and REST services, but I'm not using them in production because I don't like the overhead of REST. Actually, I have a microservices library for Node.js, and I'm using that, which has its own TCP servers and clients in each service, so that there's zero overhead and like the communication is really fast. Because like you have to do 20, 30 calls for each request, and if you have the HTTP overhead of cookies, of everything else, it won't work. there will be huge delays. So you have to eliminate that. That's why I don't like queue-based mechanisms or Redis pub-sub mechanisms for microservices. The overhead is too much. You cannot get good performance out of it. That's why I rolled out my own solution as a TCP client-server stack, and it's basically open source in GitHub as well that you can use. And yeah, I don't recommend HTTP. Maybe GraphQL would make the situation a little bit better instead of REST, but I'm not sure. And again, the first question was, how do you start microservices? It's a huge debate, basically, in the industry, whether you start with a monolith and then go microservices, or whether you go microservices directly. It depends on your experience. If you are doing it for the first time, you should better start with a monolith, because if you fail to do microservices, you'll have a backup anyway that you know how to build. But if you did it a couple of times, if you did a couple of projects with it, then you should definitely start with a microservice. It doesn't bring you any benefit to start with a monolith, basically, because you already know how to do the architecture. And this also goes for software architecture. If you exactly know how to do the software design in terms of domain-driven design, and if you can draw the boundaries between the different models and domains in your application, yes, even if you didn't do any microservices before, you can directly start with a microservice application. Because the idea is about separating your application and your code base into different applications that interact with each other over a known channel, over a known contract, which is an API documentation. If you can do this, you can do microservices from scratch. Yeah.
The last.
Hello. Thank you for your speech. It
Thanks.
was really great. My name is Vitaly, and I am almost architect in OneInc. And I have a question. It's not a technical question.
Yeah.
How to change the mindset of top management in organization to start at least a research on how to move your monolith onto microservice architecture?
Yeah. This actually isn't also only pertinent to microservices. Like any change in the organization will be blocked by top management, right? Whether it's microservices or something else, a new tool or library that you want to use. And unfortunately, I have an answer that I applied many times over the last 15 years, which involves a lot of manual effort on my side. If I want to introduce a change to a company, and I did in several of them, I use my own personal free time to implement not only prototypes, but actual working versions, and then demo it to everybody in the company. The good thing is, if it's related to technology, it's relatively easy to see if it's a better approach or not. And if by the end of that time where you implement it on your own, you see that it's really well worth the effort to, or invest to change the approach, then probably others will follow. Really slowly, you'll have to do a lot of convincing, but if you have a prototype at hand, it also shows that you are dedicated to this solution. And like, you put in a lot of blood and tear and sweat in this, and it's a good indicator for top management. Hey, like, this guy is really addicted to this solution, and he invested so much personally, maybe it's worth to give a go. Maybe we can start with a little introduction with a prototype team to try to do it. And if you really actually solve one of the team's problems, you can say, hey guys, like I worked for 10 days on my own, and we can now replace our, I don't know, shipment model or service with this microservice, and it will work. It's fully compatible. And yeah, why not we switch over? And this will basically fire people in your technology team. The more developers and middle management in your technology team you can get behind you against the top management, the better luck you have. So you have to get support from your own team first by doing their work on your own, unfortunately.
Thank you. Good point. Can I ask another one question?
Okay.
Just
1 minute.
1 minute.
And I'll be fast too.
How to define if microservices fit in your situation? I heard that one opinion that in monolith system, if you change one part of the system and you can predict that any others part of your system will break or not,
Yeah.
it's a good point to migrate to microservices. Maybe you have another opinion.
Yeah, no, I agree. I think it could be applied to every software system out in the world, as long as they are designed after domain-driven design. And I think it's the best way to architect software systems. So obviously, every software is suitable for microservices. That thing about dependencies breaking, it's about testing, and it will happen in microservices as well. And it will happen more if you don't have the right testing infrastructure and tests in place. So it's a lot trickier in microservices. I would say if you have a very small team, like less than 10 people, you maybe don't need to do it. If you don't have to scale dynamically, you don't have to do it. If it's a really straightforward application, you don't have to do it. But for anything else, you should do it. Thank you again.